Welcome back everyone. In the previous session we cover a few very key concepts of k-nearest neighbors concepts, the iris demo, as well as the distance matrix itself. So in this segment, this lesson specifically, we're going to start on an interesting project called Project Cancer Detection, not cancel detection. Obviously, typing is not my strong suit, as you can see. The data set that we're going to make use of for this purpose is called the Wisconsin data set. So let's just have a look at that. Already provided a link for you to actually access this as well. So you have the breast cancer Wisconsin diagnostic data sets. This is this provided in 1995, so it's a little bit old, but nevertheless is a very useful data sets for us to actually learn from. The actual description of the data itself is provided here. It's quite long. There's a fair bit of information here. So what I've done here really is actually extract all of these relevant information over, and let me just change this to raw so that you can actually look at it carefully. Okay, so do go ahead and download the data and save it to your desktop. This is the data folder itself. If you have a visit, these are all the data sets. What I download is the data here, which I believe is this one, WDBC. Yeah, this is all the data that I've downloaded. So this is the largest one here, 121 kilobytes. Okay, the data is already downloaded. So for now, what we want to do is actually import that. So let me just import it so that we can actually have a look at the data side by side with our descriptors so that we can actually compare them at the same time. Okay, so the other thing that I've done is that because typically with these data, when it actually comes through, it does not have the so-called column descriptors. I've actually used all of these column descriptors. I've renamed some of these. So you have the sample code number, I call it ID. You have the clump thickness, uniformity of cell size, uniformity of cell shape, marginal adhesion, the single epithelial cell size, bare nuclei, blend chromatin, normal nucleoli, mitosis, as well as the class. So basically it's all of these I've provided as the name of the column and removed the header. So let's have a look at our data. This is the first 5, and what you have now is the actual ID itself, the clump thickness, the uniformity, and all the way to actually the class itself. Now we do need to actually do some data pre-processing, so let's start with that. We do need to actually see if there are actually any so-called null data sets. Now this doesn't always actually pick up everything, so let's look at the actual info itself to see if it actually does inform us of some of these. Other things that you can actually observe is that, hey, you actually have a non-null object here, so it's not integer, and that's where scikit-learn library will actually have a problem with it. So it's object here. The strange thing is that it actually shows you that it's number here. So what's going on? So this is where your ability to play around with the data to understand how it works really actually important. So we do need to do some preliminary investigation. Oops, describe. Suddenly got into English mode. Okay, describe. So we have 699, and what the other thing that we do want to know is what are the actual value distribution value counts. So okay, this is where our culprit is. That's really the reason why it is actually an object rather than integer. Although it says it's integer here, the info here actually picks up some object in here. What are the object? There is the question mark here, and there's 16 of them. Okay, so that's really the key thing here is so the question now is, how do we drop okay, so we want to actually just remove that altogether. So the first thing now is that yes, we are still looking at the bare nuclei. Okay, nuclei. Okay, is equal to this question mark. Okay, can it pick up? Yes, it does pick up. So now we just want to actually have a specific selection of these only, and this is the all of the rows and the samples of within the data set itself that actually have this issue here. Now, before we go on and start removing these rows, we just want to actually have a look at the class itself that relate to it. You have 2, 4, and the rest are 2s. Now, the good thing is that we do have a lot of data, but nevertheless, it pays to actually just study this a little bit just to see if it actually will skew the data too much or not. So that's the reason why we do need to actually do some of these investigation. And if you actually remove, if you're in an unfortunate situation whereby you have all of these question mark and all of these question mark happens to associate with one class, and if you remove all of the question mark, it removes the whole class itself, then you have a problem. That's where you need to maybe collect more data and figure out how best to actually remove or work around that issue or impute data. So for now, we are fortunate in that we don't have that issue. Our data sets actually have 458 observations of 2 and 241 observations of 4, so it's not going to be too severely affected by these that we remove here, and there's 16 of them, so we're removing 14, 2 and 2, 4, so it's not too bad. It's not good, but it's not too bad. It's not going to turn into a disaster. So the bare nuclei, still the one that we actually have issue with. So we're gonna change or just replace the question mark with nan, not a number, and true, and then we're gonna use the dropped df dropped na function that comes with pandas. Okay, so that will remove that. So okay, so just note that for class. So remember, we actually have we've done that part of the cleaning now. We want to move on to do a little bit more cleaning in terms of our class. Notice there's a 2 and 4. Remember I mentioned before that with data pre-processing, you need to understand the number, how the machine learning algorithm interpret the numbers. Here you have, although in this case it's not too bad because that's our target variables, it's still not ideal. 2 and 4, we would have preferred 0 and 1. This is where you need to use a little bit of your imagination and figure out how best to work around this. So this is what I come up with, but couple of things before we move into before I move into showing you how I actually convert that into a 0 and 1. For now, we just need to understand our data a little bit. Okay, note that for class, okay, 2 is benign, okay, benign, and 4 is for malignant. Okay, the good thing is that the actual data itself is not too skewed. 458 about 2 to 1 ratio, so 458 to 241, yeah, it's about 2 to 1 ratio. It's not too bad, not ideal, but it's not too bad. So we just so this is how I would actually solve the issue of 2, 4 and convert it to 0 and 1. I'm gonna less the whole column by 2. All right, that's the first thing that I will do, and then just basically, sorry, I guess probably the best way is to just show you rather than keep talking. I'm going to take the df class. Okay, I'm just going to write a formula here. Okay, take the whole thing and then divide it by 2 and then less 1. Okay, that doesn't come out well. Let's see if this comes out well. Again, that doesn't come out too well. So let me just do it this way. Fraction, FRAC. Okay, yep. Open up another fraction. Okay, that's better. So I'm gonna just take the, in fact, I like this to be text. Okay, that's better. So I'm going to take the whole column, which is the class column, the whole thing divided by 2 and then less 1. So if you take the whole thing divided by 2, so that will convert it to 1 and 2, and if I less 1, that becomes 0 and that becomes 1. So that's what we're going to do right now. So the nuclei, and just do the value count first before we actually do the actual transformation itself. So if you look at this, notice that the what do you call it, the question mark has indeed gone. All right, so the next thing now is that we do need to actually change this to just transform this right now. Okay, so let's do the class. Let's go to class. Okay, divided by 2 minus 1 as I shown in the formula itself. So now if we take df class and look at the value counts. Okay, let me move this up so that you can actually see. Okay, now I notice that it's now 0 and 1, and we have removed completely the issue that we have earlier. Okay, so which is 2, 4, now we convert it to 0 and 1, something that we prefer to work with. Okay, now let's store the data into our x and y as we familiar with. So we're gonna copy the whole x, the whole data frame. So let's just show the data frame's columns name first of all. Okay, so the columns come with these names. The class obviously cannot be in the x itself. X is our predictor, so we don't want to include that. We also don't want to include the ID. ID obviously has no information at all. It's just a case ID. So we're gonna remove the ID itself and class itself. So we're gonna make use of pop to remove that. Okay, and store the rest into x, and I'm just gonna remember this because we're gonna need it later. Okay, all right, that's done. The next thing now is our y. We just need the value of the class itself, and that is pretty much it. Okay, right. Finally, the one last thing that we do want to do is to scale our data. So sklearn pre-processing, and we're gonna import the standard scalar. Okay, and we're gonna x is equal to standard scalar. I'm too lazy to instantiate it, so I'm gonna just do this in a chain. So transform, you can instantiate it if you want to, but for me, I just want to actually immediately and directly convert it. So we have the standard scalar, that's the first portion here, which is standard scalar. Bracket here is our instantiation dot fit transform, not only fitting it but also transform it concurrently. We're storing x, the values, and directly into actually the x itself, so just replacing it all together. Okay, right, what is the warning here? Data conversion error. Warning, data with input type object was converted to float 64. This is the issue that we have. So let me just df info. But they've already removed the issue, so there are no more issue anymore because we've already removed the question mark. Hence, it actually is able to actually proceed without much problem. All right, finally, we are ready to do our training. Okay. Again, I'm sure you know by now what we're gonna do. We're gonna split our data into training and test split. Okay, and we store this into data frame 1. So pandas data frame, and we'll take x, which is this one. This is already this is the scale data. But we just want to leave the now I just want to put some the name back, which is what we store earlier, x, the column name, which is this, the purpose of this. We store the name, and we just want to just do a bit of visualization. Okay, just so that we actually see what has occurred. This is what happened with the scaling. The scaling has changed the data. Remember what we had before was just these numbers here, and obviously the machine learning algorithm is going to have a bit of issue dealing with these. Yes, it's not so bad when it comes to KNN, but nevertheless, we want to do this in case we want to actually compare KNN against other machine learning method. But for now, we're going to make use of that and split out train and test data as we normally do, so that we can actually start training our data, training our model. So well, that's actually kind of a misnomer, because we, as I mentioned before, KNN is not really a function-based or training-based. Okay, but for now, let's go into this. We still need to nevertheless do this train test. I'm going to use 80% for the training and set our random state to 42. The question that you had earlier when I was explaining that wasn't really well explained, by the way, is why do you actually want to still do this? The answer is actually go back to our cross-validation lesson that we did in section 3 in the regression. Remember that we split our data into train and test. Within the training itself, we also do perform cross-validation, leave one out, or cross-validation tenfold, typically 3 if you want to as well. But the idea here is to actually run multiple training and also test within sample to see how our model will perform within sample, and then later on, before we move into the actual test itself. Although we're not actually trying to get the KNN to learn a function, what we are doing is that we are assessing the performance of KNN in sample and also out of sample. That's really the purpose and the whole idea of actually doing this whole exercise. Okay, now we've already talked quite a lot. We already covered a lot of ground. I see that we are running a bit of short in time. Rather than forcing this through, I'm gonna pause here. I do want you to actually do a simple exercise. The exercise is a little bit different from what you've been used to. You notice that here what we've done is we use standard scalar, and this is the part that I want you to remember a little bit of what we did in the past, which is what are the other types of pre-processing library we can use or method we can use outside of standard scalar. There are 2 others. I'd like you to think of them and apply them in this situation and see, and also visualize it to see what actually occur or what happened to your data. So pause the video, try that out. This is really an exercise to help you recall a little bit of what we've learned in the past. So pause the video now. When we come back, I'm going to summarize the lesson. Welcome back. I hope you did give that a go and try that out to see what it actually was like. Yes, there is the min-max and there's also a normalization. Okay, I did the min-max just using 2 lines imported and using the actual chain operators of pandas. In essence, the min-max, the fit transform of the original data from the data frame itself, and finally remembering or copying the actual columns itself. We're just visualizing the top 5 samples, rows of data. So notice that compared to the standard scalar, it's actually quite different. Okay, and this is the really interesting part. And but nevertheless, the whole point of this exercise is actually just to give you a view of how things actually works. Okay, hopefully you do remember the lessons that we've learned earlier. So in this lesson, just to summarize, what we've covered is that we started on the project or cancer detection. We have downloaded the data from Wisconsin, and we understood our data, did a little bit of very preliminary or very just a light touch of EDA just to understand our data a little bit, tidy up our data, and just basically doing a bit of data cleaning, removing some of the data, just making sure that we pre-process it properly and using standard scalar here so that we can move on to fitting our model, which is what we're going to do in the next video. Thank you again for watching. I look forward to seeing you in the next video.